AT&T, I work on the Arrow program, and Arrow is the Application Resource Optimizer. Our goal is to help developers, testers figure out how to make their apps run faster. And if your app is running faster, you're using less power, less battery, and you're probably using less data on the network, which is something that customers are worried about. And so, developers make a bunch of mistakes every day, and there's sometimes that kills your customer's battery. And so when you make a connection to the data network, studies have shown that 40% of the screen on battery power is from data connections. When the screen is off, it's 70%. And so this is a screenshot from our tool. It's a free open source tool called the Application Resource Optimizer. And you can see packets. And so what we're looking at, we're actually looking at the packets of every single mobile app that's going through on the network. We'll talk a little bit more about that. But what's interesting here is at the bottom, there's this line called the RRC state. And that has to do with on mobile, there's a high latency to set up a connection. And so when you turn on the radio is on for another 10 to 15 seconds, no matter what. It doesn't matter what carrier. It depends a little bit which carrier, where in the world you are. But if you just send, if you watch a video, the radio's on for 10 seconds. If you just send, 50 bytes of data, the radio's on for 10 or 15 seconds. So it's really important to understand that because you're not using your customer's battery. And like I said, so cellular networks are high latency. And so if you don't optimize your content, you get delays. And so studies have shown that if there's a 500 millisecond delay in stuff showing up on the screen, people get frustrated. 26%. People stop paying attention. It's obviously not what we want them to do. And there's a study out there, this is a web study, so this is desktop data. For every 100 milliseconds, Amazon found that they lost 1% of revenue. That's a big number. And my favorite stat of all time for performance is, if your site is slow, people throw their phone. And so when you see people with a broken iPhone screen, it could be our fault. So you have to be really careful about that. This is actually, in Finland every year, they have a cell phone throwing contest. And I think this woman's been channeling a year of frustration as she chucks her phone as far as she can. So is performance holding up back your app? And so there are all these things. I've kind of hit on a bunch of them, like acquisition and how long, how people use them. These all are affiliated with the performance of your app. And so when I think of performance, when you think of people discovering your app, it's kind of like people, they hear about an app, and they think about it, and then they download it. And then if they like it, they kind of put that breadboard on in front, and they tell all their friends, I've got this app, it's awesome. And they tell their friends, and you get this awesome organic, positive reinforcement loop. You get more customers. But if your app stinks or has poor performance, you fall out of that awesome self-reinforcing cycle. And studies have shown that 48% of customers, if they don't like the performance, they uninstall your app. They don't use it anymore. So we don't want to be there. So how do you understand app performance, and then how do you test for it? So sometimes it's a big problem. So, you could say that my app is so big that we have no problem with our app. That's happened about 100 years ago. They said that about a boat. But in our study, we look with Arrow, we reach out to developers. We found 98% of apps have some performance that can be done. And so we like to think of Arrow. You like that, Al? All right. No, but sometimes it isn't always the iceberg. It isn't the big thing that sinks your app. It's the little things. And so this is a sculpture of the Danish boy sticking his finger in the dike to prevent his town from flooding. And so minor issues you find in testing, it's not a big deal, it's not going to be a problem. One of my coworkers tested an app, and they saw this 4K image downloading all the time. And the developer's like, no, it's not a big deal, it's just 4K. And then they got some press, and they got lots of people using it. And their server went down because there were all these requests for a 4K image. They weren't caching properly. They fixed it. So what we want to do with our tools and some of the best practices we have, we want to help you find those issues early so your app doesn't crash, you don't get that bad press. But let's talk about how bugs are found. 44% of all bugs, testing on apps is hard, I get it, but 44% are reported by users. And so this is my library app, and for those of us who live in North Seattle, the acronym there might make sense to you. It's the county just north of us. 20% of the issues are reported in the App Store. So now your customers are finding out your app, they go to the store, they want to download your app, and they see that it's crashing. I'm not going to download that app personally. So what are your customers doing? And lo and behold, here are some app reviews. It of course closes whenever I try to log in, right? Same app. So how can we help with that? So we've got this free open source tool. It's called the Application Resource Optimizer. You can test on iOS. You can test on Android. I talked here last year, and I talked about how you need a rooted Android device. And there was a native iOS. So now you don't need root on your Android device. You need native iOS collection. You can look at your app. You can see the data going back and forth and help you figure out how to reduce the battery drain, reduce the data, improve the speed. And then the last bullet here is CPIA has a website called knowmyapp.org that shows how lots of apps are using data, where they're putting up a lot of best practices on how to make your app run better. And a lot of that data is coming from the application users. And so now we've gone into the stupid developer tricks. So this is the stuff that we've seen, and I'm going to show you guys what we've seen in real apps so that you don't do it. And so this is an app, I'm calling it Find My Goat. It's not really called Find My Goat, it's a different application. But the idea is we want to find the goat. And so this is a trace from Arrow. And what this app is doing is every 5 seconds it's pinging the network. Where's the goat? Where's the goat? Where's the goat? When we first tested it, nothing was a problem. But then something happened. And the CEO of Find My Goat called a person very high up inside AT&T and said, your network is breaking our app. We went and tested it with Arrow. And what ended up happening was, instead of sending the same data down the same pipe, they were opening 18 connections from each customer to the server. So 18 connections instead of 1, so 100,000 customers. Instead of 100,000, we've got 1.8 million IP addresses. They're getting IP permissions. They were creating a distributed denial of service attack against themselves. Don't do that. That's bad. Lose money. This is another app where and the point here is, so in Arrow, we grab screenshots while we're running the trace. And so you can see there are all these spinners. And so we've got images loading. And that's great. There was a post where they actually saw research. This app added spinners, and people started complaining that the app was slow. And it was the perception. They didn't realize it was slow until you put the spinner on there. When you put the spinner on there, they're like, oh man, this app is slow. So they took the spinner off. People started saying, you spin up your app. And they're like, Facebook did a study on iOS, and they did an A/B testing with 2 different spinners. One of them looked like the iOS spinner, and one of them was this Facebook unique, weighting thing. When it was the one that looked like the iOS one, they blamed the phone. When it was the other one, they blamed Facebook, so they went to the one that blamed iOS. Right? It's all perception. And so sometimes it isn't even actually making your app faster, it's making your customers think that your app's faster, and that's enough to make your app faster. And so that's the quote here is, when we put in indicators, people were saying it was slow. We pulled it off. And so here, what we're seeing here is now this app with all the spinners, they're downloading all these images. And it's taking a long period of time. So if you can make those images download faster, you actually remove the spinners. This is not the thing. Another thing to think about is here in Seattle, and in the different states especially, we're really, really biased. 97% of people in Canada and North America have access to LTE. That's unique in the world. In Western Europe, it's in the 80s. 80% of people have access, and it drops off precipitously from there. So if you're building your app, think about what customers outside of the LTE zone look like. And so this is data for Africa. And so black is LTE. So they're saying in 2017 there's going to be that much. It's not a lot. And 3G is yellow, so it's still not a lot. There are a lot of people on 2G in Africa. Here's some data in China. This is from 2013. This is before LTE were actually rolled out in China. But there's 270 million Android phones in use in China. And 31% of them get all of the data on 2G. So think about what your app looks like. Think about what your mobile website looks like. The more data you're sending down, the more likely your app isn't going to be useful outside of areas that have really fast networks. Another thing to look at is, as a developer, it's important that we all eat and we all get paid. But this is an app that was downloading ads every 30 seconds. And you can see that the ads weren't super concise. The packets are really drawn out. And so the radio is on. The radio almost never turned off. because of the ads that we're constantly downloading. And so if you're doing something like that, just make sure you look in there, make sure that the third-party SDKs you're adding to your app aren't actually adding to the battery drain and some of the other issues that could be happening to your application. I want you to think about consistent, constant improvement, because we look at apps, they get better, and then you start going into your development and you forget about performance. And so it's a constant thing. You have to keep looking as you're adding new features. Is this performing? Is this hurting the ability of my app to run, to be fast? Is this causing my customers to walk away and go to my competitors? It is a constant thing. This is not something that you just do once and you walk away from. It's something that should be part of your development process. As you're building apps, look at performance, look at ways you can make your apps run better. We see a lot of excuses. We talk to a lot of developers. We have a lot of people like, what's the point? And hopefully I've shown you that when you increase your engagement and you increase your users, and you make your users happy, that's the reason you want to do these things. Because if people walk away from your app, it's going to be really hard to continue with making it with your application. And so when we want to talk about performance testing, we've got Arrow, and there's a URL here. This step will be up online, so you don't need to copy the stuff down. The App Quality Alliance is a group that has a bunch of performance testing criteria. CTIA is here with Know My App. GSMA has some stuff up as well on how to make your app run faster and steady performance. In general, keep it simple. We've got a bunch of free tools. We have a tool called the Network Attenuator, which I'd love to talk to you about a little later. I don't have enough time to get into it. Qualcomm has a tool called Trepid. Android has a slew of free tools. There are a bunch of tools inside iOS as well. Run a couple of tests. When we run with Arrow, we say do 2 tests. It takes about 40 minutes. Do the analysis. It gives you 25 best practices. It tells you where you passed, where you failed. It's really easy. It's pretty self-evident. When you see a red X, that's bad. You see a green check mark. You don't have anything to worry about. But what you find really might surprise you. So these are the 2 tests we typically run. We run an active test, really using that. And then idle use, so what the app is doing, whether or not the customer is interacting. We see things like, are you compressing the text files you're sending across the internet? Right? So if you send a 20K file that's uncompressed, or you compress it, it's 4K, which one is going to get to the customer faster and be displayed to the end user faster? The one that's compressed. I talk about closing connections, and so that, if you don't close the connection right away, packets turn on later. It turns on the radio, it drains the battery. If you can avoid draining the battery, you close the connection. When you're done with it, you won't drain the battery, your customers are happier. Their phone makes it to the end of the day. Wouldn't it be great if you didn't have to plug in a phone all the time? I think that'd be awesome. Duplicate content. Downloading the same stuff over and over and over again, or caching it locally. It's a lot faster reading from the local memory of the device rather than downloading it. GPS. We see a lot of applications just constantly ping the GPS or forget to turn off the GPS, because sometimes if you're testing, like in a building like this, imagine those aren't with us, sometimes you don't get signal, and you can't get a GPS, but we just see the phone never forgets to turn it off. You just keep saying, it gets signal eventually. So put fallback in the way you turn off the GPS if you don't get a location at a bit of time. We see apps doing periodic connections. We saw the Go application earlier that was just pinging every 5 seconds. Figure out what the optimal time frame is and try to minimize it so you don't kill the batteries. The customers are getting the data they need. Your users are getting the right data, but you're also not hurting the experience. Analytics and advertising, really important. Use those analytics to figure out what's going on in your app. But if they're reporting all the time, again, you get your battery drain. So at AT&T, we do all of this testing on everything that's preloaded onto our devices, because obviously we want to make sure that the apps that's on every phone isn't killing the batteries and killing data plan. And so these are the kind of really basic thresholds. I mean, we're being really generous here, but if you're a preloaded app on an AT&T device and you have over 5% duplicate content, you're not going to get preloaded on a device, right? That's too much. You're wasting our customers' data. If you're using a lot of power because you're pinging all the time, or periodic connections, you're not closing your connections, you're wasting the power, you're not going to get on our devices. Using the GPS a lot, there absolutely need GPS. The Yelps and the find the restaurants and the get directions and all those sorts of things, they need GPS. But if you're not one of those apps, no GPS, you don't need that. And then compress your text. sends stuff efficiently over the network. It gets to your customers faster. They can use it. It's actually saving you money on the back end because you're not sending all that data to your network as well. When we're doing our testing, these are some of the collection tips we have. Try to emulate it really, because if you look at our test, we want to really see what customers are doing and see how it works. Build some good test cases. Don't limit testing. I said 2 tests, an active test and idle test. Look at all the various test cases you have and try to find out where your app is efficient and where it's inefficient. We really want to help you. And if you have questions about your traces, you can contact me or someone on my team, and we'd be happy to help you with your traces and figure out what's going on. Be curious. Sometimes you do some weird stuff. I spend a lot of time trying to figure out what's going on here. And it's not my app, so it's a little harder for me. But we see lots of interesting stuff. So let's figure it out. Let's try to figure out what the app is doing, why it's doing it, and how we can stop it from happening. If you're interested in learning more about high-performance Android apps, I've got a book that I'm writing. It's not finished yet, but 5 of the chapters are up. You can get an early release, and they're off this week only. How's that look like? Again, so I've got a bunch of links here. If you have any questions, I'd be happy to take them now. Yes?
How do you distinguish between the perceived experience of slowly slow down and slow?
So you're asking, so if it looks,
Is there a perceptual difference that we have like us? We gotta give it a chance to versus I look
there's so the question is, how do you tell if is it a perception thing or is it actually just really slow? And I don't think customers care, right? So if your app starts up and you're downloading 12 megabytes of stuff because you need that stuff before the app can be used, or if you're just slow to start up, I don't know if it really matters. I think customers just see that you're slow. So the idea is try to look. So I know Instagram just recently posted a thing where they realized that they could postpone some of those things to after the screen had popped up. And so they were able to, they were pretty fast to start. They were like 1.6 seconds, but now they're under a second for the app to start up. And stuff happens afterwards, but people don't notice. What they notice is that when they click that button, it's really, really fast for the app to start up. So I think it doesn't, in some ways it doesn't matter. You just want your app to be fast. So you're going to see data coming back and forth. So you'll see the connection endpoint. And I don't know if I have some more slides here. So this is an AT&T app that we made better. I have no pictures of those. You can see that. So here's an app. And so this is Kelly, as you go back to your question, this is an app that was downloading 6 megabytes of stuff every single time it started out. And then we talked to them, and they did that. So look at the second startup now. You can't snap your fingers as fast as that app started up. So what you can do in your app is right here, we map every TCP connection. So you can see the endpoints in the app, and you can say, oh, this is connecting to api.whatever.com. And you'd be able to see what's being downloaded. You can see if they're compressing data. You can look at, and we have a waterfall chart. So I don't know if you know about waterfall charts, but it's a way of seeing how long it takes for every single step, how long is the DNS go about how long it takes. You can actually chart how long it takes for those steps to happen. And you can also test it over Wi-Fi, test it on 4G. You can go up to the movies and test it on 3G. All right, if there are no other questions, thank you very much. And if you want to talk about Arrow,